Question number 20. Which of the following statements is correct regarding the reaction between a carboxylic acid and an alcohol to give an ester? The reaction will look like this. Let's say this is our carboxylic acid and this is our alcohol. Now this reaction is a reversible reaction which is catalyzed by H plus ions. Now the OH group from the carboxylic acid and the H plus hydrogen atom from the alcohol will react with each other to form a water molecule. Hence we will get the ester bond. Now this is the ester bond. Ester bond. Now let's look at the mechanism. To understand the mechanism very well, let's mark this oxygen as a radioactive oxygen. It's in red color. Alright, the mechanism. Now the mechanism is a nucleophilic substitution. How do you know that? The OH group from the carboxylic acid has been removed, so it's a substitution reaction. The substituted group is an alcohol group and it has lone pairs here, so it should be considered as a nucleophile. So it's a nucleophilic substitution. The reaction starts with the attack of OH group from the alcohol to the carboxylic acid. Now this oxygen is a radioactive oxygen. Now what happens here is the lone pair from the oxygen in the alcohol will be given to the carbon of the carboxylic acid. And what will happen? The H plus will accept the electrons that are removing from the C double bond O group. Now when the lone pair goes and attack the carbon here, it forms a bond with this oxygen. So in order to form the bond, the carbon should have an empty orbital. How does it empty its orbitals? By removing the pi bonds. So these electrons are given to the H plus. Now we will get, there's a OH here, this is the catalyst H plus here, and there's another OH there, and we get the alcohol groups attached. It's a plus now. Now this compound will remove its oxygen by giving its electron to the, remove its hydrogen by giving electrons to the oxygen to neutralize the plus charge here. Then we will get RC, this OH, this oxygen is radioactive, this is the catalyst hydrogen, and this OH is there. Now there's a OR group. Now two hydroxyl groups on the same carbon is not stable. Therefore, a water molecule will be spontaneously removed. In order to do that, it has two methods of removing the water molecule. This compound can remove a water molecule by using this OH and this H. So we will get an ester like this. Now when this OH is removed, the carbon gets an empty orbital. When this hydrogen is removed, the oxygen gets an empty orbital. So both of them can complete their octets by making a bond between them. So there will be a carbon-oxygen double bond, and this OR group is also there. The water molecule will be radioactive because the radioactive oxygen is connected to the water molecule. Then there's another way of removing the water molecule, that will be removing this OH group with this hydrogen. So it will look like this. Therefore, the ester molecule will have the radioactive oxygen now. It will be this oxygen, because this oxygen is there now. Look at the purple color pathway. This purple color H2O molecule removed. When this water molecule is removed, this radioactive oxygen remains in the ester molecule, and this OR is there. Now the water molecules are not radioactive. So we get two types of esters and two types of water molecules, which means from the carboxylic acids and alcohol reaction, we get 50% of radioactive esters, 50% of radioactive, here esters, here radioactive water molecules. So this is the complete mechanism. Now let's look at what are the statements that they have been given. The first statement, the overall reaction is a nucleophilic addition reaction. No, it's not an addition reaction, it's a substitution reaction. So this statement is an incorrect one. Second statement, it is a reaction in which the alcohol acts as a nucleophile. That is true. It's a nucleophilic substitution reaction. Third statement, it is a reaction which occurs with the cleavage of the OH bond of the carboxylic acid. The reaction 50% of the time happens like that. The OH group is this one. This is the OH bond. Now the OH bond is removed only 50% of the time. So we cannot say for sure, let's say for 100% sure, that always the OH bond breaks. Sorry about that, not the OH bond, not this bond. The OH bond is this one here. This is the OH bond. The OH bond is broken only the 50% of the time. Therefore, we cannot say it will always be broken like that. So this statement is not that correct. Fourth statement, it is a reaction which occurs with the cleavage of CO bond of the alcohol. The same argument goes with this statement like in the third one, because the CO bond is also broken only 50% of the time. This is the CO bond and it breaks only 50% of the time. Therefore, this statement is also incorrect. It is an acid-base reaction. It's not an acid-base reaction. Carboxylic acid is a acid, but it doesn't give the H+. Therefore, it's not an acid-base reaction. It looks like an acid-base reaction, but it is not. So the answer for the 20th question will be the second answer. Okay, let's move on to the next question.